So for my science experiment, I have done the bust the rust, and I did an introduction, and it's rust is a type of orangey brown corrosion that happens when the steel is exposed to liquid air. My project is to compare different liquids to see which one causes the steel plates to rust the fastest. My project is being observed over 5 days. Over here I have my project goal, and it's to discover which liquid rusts the steel the fastest over a monitored period of time. And also over here there's the materials and equipment. There's 9 steel plates, 1 control and 8 different test pieces, 8 different liquids to test: lemon, coffee, water, salt water, bleach, Sprite, vinegar and acetone / nail polish remover, a wooden block to place the test pieces on, a pen for labelling the test pieces, and a camera to note and record your findings. Over here there's the steps of the experiment. Step 1. Grind your steel plates and polish them with a rag and brake cleaner, and that's the photo for that. Step 2. Place the plates on a block of wood and label them like this: L for lemon, C for coffee, W for water, SW for salt water, B for bleach, S for Sprite, V for vinegar, and A for acetone. Step 3. Pour 1 liquid onto each steel plate and observe the rust starting. So over here is the different liquids, the rag and the brake cleaner, and the test plates on the block of wood and the labelled ones, and then there's the rust that's just started. Step 4. Take photos of the steel plates at half an hour, which is this one, 12 hours, 1 day, 2 days, 2.5 days, 3 days, 4 days, and keep taking photos until you get to day 5, and record your findings each time. Step 5. Get all the notes to find your photo you've found on your photos and information, and present the experiment so people can see. I have done that here, and there's lemon, coffee, water, salt water, bleach, Sprite, vinegar and acetone. I did a conclusion, and I have discovered that the vinegar rusted the steel plates the fastest out of all the liquids I tested, and the rust on the test plates look much deeper than any other liquid. Lemon juice has a thinner type of rust across the whole test plate, like surface rust. Coffee, Sprite and acetone have shown similar results of the dark orangey brown colour across the surface of the test plate. Water seems to only have caused a small amount of rust to start on the test plate, and through the experiment didn't really get much worse. Salt water seemed to cause the least rust. Bleach caused a chalk-like effect on the edges rather than across the whole test plate. For my findings for lemon was lazy and started showing much later than all the others, but it turned out to be a sunflower yellow. Then for coffee started with small dots and got larger, and then eventually filled the plate. My findings for water started to show little dots of the rust and stayed the same over 5 days. And the same with salt water. Salt water made no rust on the plate, but absorbed all the water and left the salt on the surface. Bleach started very late towards the end and started showing a chalk colour effect around the outside, and then faded at the very end. Sprite was the 5th plate to rust after the acetone. Sprite made rust dots like the coffee. And the water. It didn't really get much worse. The findings for vinegar started showing a yellowy colour over the time and then rusted around the whole plate and turned to an orangey black colour. And finally, acetone. Acetone started rusting in one patch and it stayed that way throughout the whole experiment.
So I did kitchen science, and I used my class, my sister's class, and my mum's class and the teachers. So we had 3 questions. We had how does the quantity of sugar affect the taste of a cookie? How much sugar is too much? And what amount of sugar tastes the nicest? Predictions. This was my prediction. I think the teachers would like the extract recipe and the kids exact recipe, and the kids would like the one with the most sugar. I don't think anyone would like the one with less sugar. This is my sister's. I think that people would like the one with the most sugar. The recipe is 2 3/4 cups of flour, 1 teaspoon of baking soda, half a tablespoon of baking powder, 1 cup of butter, 1.5 cups of white sugar, 1 egg, and 1 tablespoon of vanilla essence. We made 3 lots of cookies. We made the one with the original recipe, one with less sugar, one with double sugar, and we tested a year 1 class, a year 4 class, a year 6 class, and some teachers. The result was that most people liked cookie number 3, and hardly anyone liked cookie number 2. Maybe the recipe is wrong and we should have more sugar. People love sugar. The quantity of sugar also changes the look and shape of the cookies. Most people liked the one with sugar, and the quantity of sugar didn't affect the taste of the cookies. We asked them to choose their favourite cookie.
So what I did is, why doesn't the water fall down? So what you do is you get a cup of water and a piece of paper. You put the paper on top of the cup and you turn it upside down and you lift it up. As a result, the water shouldn't fall out. And don't let any air go in, because why doesn't the water fall down? That is because there is air pressure to push the water go upward, but the air pressure can only push up an amount of water. Like, for example, it cannot push up a bucket of water. Yeah, and I'll do the experiment on the night.
Very good.
So I did for my experiment was bouncy eggs, and these are the materials needed: a raw egg, glass or jar, and any type of vinegar. So instructions: get a raw egg and carefully place it into a jar or glass. Fill the glass with white vinegar until the egg is fully submerged. Leave the egg in the glass for 1 to 3 days. Each day, check on the egg. When it has become rubbery, you'll know it's ready. Remove the egg from the glass and rinse it under tap water. When rinsing it, gently rub the white film till you have a rubbery egg. 5. You'll notice that it feels rubbery like a ball. Lift the egg 1 or 2 inches and watch it bounce. 6. When you're ready for some messy fun, lift the egg higher, then let it go splat. Conclusion: when the egg is submerged, the vinegar begins to dissolve the shell. As time passes by, the shell will completely dissolve, leaving the thin layer of the egg. The result is on an egg that looks and feels like a bouncy egg. So this is mine, but it still hasn't formed yet. And this is a diagram of an egg. That's the two membranes. That's the egg white, the yolk, and the air chamber. When the raw egg is placed in vinegar, a reaction will take place, causing the first membrane or shell to start fading away and lose its color, also giving it a rubbery feeling.